Welcome everybody to another Monday night session. Apologies for the late start, a few little technical difficulties this evening. So Jennie McCormick is going to talk to us about her journey in backyard observing. Over to Jennie.
Thank the AAS for inviting me to give this presentation tonight, but more importantly to Steve, who spent a bit of time trying to work out the software. So thank you, Steve. So tonight I wanted to take you all on a journey from my perspective, of course, of what can be achieved from backyard observing. But first of all, I want to take you on, have a quick look at how my love of astronomy progressed to what it is today, in my opinion, quite serious research astronomy. We'll take a look at the equipment I use, discuss the collaborative groups I work alongside of, and we'll end up with some of the exciting and I must say rather unexpected discoveries I've been involved in so far. Okay. So I'm sure many of you watching this presentation tonight can remember that very first spark of interest you all had in things spacey. You know, whether that was from seeing stars and constellations from a dark sky or looking at Saturn for the first time through a telescope. And I've got to say, I'll never forget that. Or watching men walk on the moon. You know, for me, the interest started in primary school and it grew and grew. So I had a real need for spacey things when I was quite young. And when our tiny new black and white TV arrived, well, there it was, lost in space. It was just what I was looking for. And I never missed any episodes of the Robinsons flying through space in Jupiter 2. In fact, I've just recently finished watching the third episode of Lost in Space, and it was pretty cool. So then in the early 70s, this came along. I mean, I'm sure you all remember Star Trek. I'm sure there's a few Star Trekky fans out there. But I mean, what more could you ask for in a spacey program? I mean, you've got good-looking captain. You're traveling through space. There's stars. It was just like, wow. So again, it was just, I wanted to know more. But being a 13-year-old at the time, I mean, seeing this man, tuning into Captain Kirk, William Shatner, to see his latest alien conquest was always a highlight. But it's still, you know, it was spacey as far as I'm concerned. Now, while I was at secondary school, there was no astronomy club, okay? That was never discussed. There was never anything to do with astronomy or looking at stars or telescopes or binoculars, actually. You know, it was always typing, bookkeeping, or how to be a good wife or a homemaker. So astronomy really back then took a back seat because I was only young, right? So it wasn't until really I was a young mum that I got a pair of binoculars and was able to scan the night sky that I got really interested in, you know, in what was up there, really interested. In fact, one thing, I just want to give a few tips as we go through this talk for the new people out there. I always carried a notebook. And so would make notes of everything I was doing. And even though I didn't know what I was looking at, I'd still make notes. Now, the binocular viewing was quite good because I just wanted to know more about what it was I was looking at. And there was an advert in the paper for a talk on the solar system at the old Auckland Observatory. And I thought, well, hell, I've got to go there. And so I did. And I'm sure many of you remember this wonderful image. So driving up to the observatory through the big oak tree driveway was, you know, it was very impressive. And then I arrived here at the observatory and this is what the view greeted me. And it was pretty exciting. I mean, you've got a dome and I mean, it's spacey. I just want to take a little backwards, just tell you a little story about those doors there, because the doors were quite, well, they were very impressive. They were very large. So that door is a very large fiberglass, very heavy door indeed. And if you look at the door, you'll see it's painted with a mural. Now, that mural was very contentious. People didn't like it. And right up until the 90s, there was people talking, oh, it's astrology, you know, we can't, not good. Now, that door was actually painted by the Palmerston North-born Pat Hanley, the New Zealand artist, who died in 2004. But that painting was actually worth money. But what I'm told is the manager of the observatory at the time, which was Glenn Urquhart, who I'm sure is listening today, he was asked or told by the trust board to paint the door, paint over that mural. And they didn't know it was a Pat Hanley. So he did, and he painted it brown. And much to the horror, of course, of Auckland, the Auckland Art Gallery, who, you know, was absolutely just aghast at what had happened and came out, I'm told, and tried to work out if they could get the paint off. Well, as it turned out, they couldn't. And I'm told that that big door, the Pat Hanley, disappeared to the tip, which was quite sad. So I'm sure it would have been worth quite a bit of money today. But anyway, back to my story. So we'll walk through those doors, and for any of you who knew what it was like in the old Auckland Observatory, you know, there were telescopes everywhere, and there were people rushing around, and there were pictures on the wall, and it was a real place to be. You know, there was stars and planets and moons, and I was in the right place. So I ended up in this room, and I'm sure some of you recognize this. So this was called the auditorium. Or the hall, as I remember it being called. And I think today at the Stardom, it's called the space room, I think. So this is what it looked like, you know, those big high back seats. And there was Glenn Urquhart standing at the front of the room, giving a fantastic presentation on the solar system. And it just stuck. It really did. That's not Glenn at the front, by the way, in this picture. That's Jennie Perwick, who lives out where I am. So it was just amazing to hear all this information, things that I didn't know. So I was hooked, and thanks to Glenn and the Auckland Observatory at the time, I decided to join the Astronomical Society. And it was the best thing I did, I have to say. So what I did, I hired a telescope, like I'm sure many of you have done, and I went out every clear evening I could with my notebook, with my red light, and with the members of the society, who I've got to say right here were really instrumental in where I am today, like talking to you, because they taught me a lot about the night sky. They showed me how to star hop, which I still don't like doing, but hey, I learned how to do it. I found out about the constellations and the stars and where they all were and what they were. It was fantastic. So again, I'm just taking in more and more information and wanting to know more. Then, of course, if you look at the bottom picture here, this picture was taken at Waharau at the Firth of Thames. And it was, I think it was a solar eclipse weekend. And so being in with a group of like-minded individuals, all sharing knowledge and imparting their love and enthusiasm for astronomy, even did it even more for me. So I was hooked. I couldn't get out. So thank you to the Auckland Astronomical Society, because you basically changed the way I do things. And I'm very grateful. Then one thing, the progression led from hiring telescopes to purchasing a telescope. So this is me when I was a young mum, and I purchased this 13-inch Dobsonian. It was called the Collapsar, because it would all come apart, which was fantastic. And I could pick it up and stick all the little bits into my car. I would spend as much time as I could showcasing the night sky to the public by taking it to my children's school, out to supermarkets and onto the street, and to my neighbours who had never looked through a telescope, not once. And they were amazed to see the moon. So it was a really important tool for me to actually learn how to use a telescope and to get my excitement, my enthusiasm for astronomy even stronger. But, you get to the point where, and I'm sure some of you out there will understand this, where you think, okay, what else can I do besides look at objects? Not that they're not nice to look at, they are. But I felt that I needed to do something like something more than just looking. So the picture of me here was in the Zeiss Dome at the Stardom Observatory in Auckland, and another chap called Tom List from Auckland Astronomical Society, we decided we were going to try and hunt for faint planetary nebulae. Now that sounded pretty good. And, I'd do something serious. But unfortunately, at the time, the Zeiss telescope, not only was it a heavy sod to push around, but, you had to get your RA and DEC coordinates. You had to do a little bit of mathematics. You put them into you dial up the setting circles. And if you were lucky, you had your little faint planetary right smack in the center. But the worst thing of all was, because it's a public telescope, people want to look through it. So once you get into doing something, you had to get off because somebody wanted to look at the moon or Mars. So, it became quite frustrating. I remember the frustration quite clearly. And at the time, my partner, Fred Veldhuis, and I, we lived in Farm Cove, and we discussed this. And so we thought, well, maybe instead of giving up your telescope time, let's build an observatory and see where we go from there. And that was another great thing that happened. So these pictures here, that's Fred in this little dome. Now, the dome was a 2.4 meter steel dome that we purchased for $200. And I can't remember how we got to hear about it. Someone had one or something. Anyway, that dome at the moment is sitting at Kumu, probably rusting, but I assure the person who's going to own it next, it comes up quite nicely once you've done it up. So, we spent many of our painting, bringing the rust, getting rid of the rust to the best we could, and get it all ready. And thanks to friends, we were able to spray paint it and get it ready for an observatory. So, that was getting the dome was quite important. So from there, of course, what happens? You need an observatory. So thanks to this chap, the elderly chap on the left in this picture here, this is Andrew Goodfellow, who unfortunately died this year. He was a life member of the Auckland Astronomical Society. He designed and built this observatory, the observatory that you can see me sitting in, and there it is there. It's approximately 3.2 meters by 2.4, perfect for me and a couple of other people. Gets a bit tight from time to time. But he did a really good job. And the cool thing about having the observatory in our backyard is that we didn't have to drive anywhere. So, because after a long day's work, just getting in your car and thinking, right now I've got to drive up there and I've got to do that, can be really taxing. So having your observatory here was the way to go. It really was. Just as a little side thing, I don't know if you can see it, you probably can't, but the desk I'm sitting on is actually the Auckland Observatory's men's toilet door. So Andrew was very, he was a collector, very collected things, and took these doors when the building was refurbished, and I have it as my desk. So that's quite neat. I always remember the men's toilet door. Now, the pier, we needed, of course, a pier. Now, being in Farm Cove, we have a lot of clay. So we dug that by hand, my children, Fred and Andrew. We dug it in the winter, 1.3 meters and 40 centimeters diameter. And it was a massive mission to dig that thing. I remember that. If you can see, if I move back here, you might be able to see the pier. So it consists of 2 3-meter reinforced concrete pipes that are spun, and they're 30 centimeters in diameter, and are packed in with a concrete plug on the top. So once the dome, the observatory was built, the dome went on. And again, thanks to Mark Boz for all his help, another Astronomical Society member, and everyone pitched in to help, which was really cool. So we ended up with an observatory. So I wanted to show you what we started out with, so you get an idea what we had. So in 2000, Fred had one of the first LX200 10 inches. Now, people talk about these LX200s as though, don't get one of those, they're really bad. Well, in my experience from having now 2, the little 10-inch and the 14, which we'll talk about shortly, have been extremely reliable. And the reason they're reliable is because they are permanently mounted on a fixed pier. So having these telescopes for public viewing, like I know a lot of observatories do, isn't a good thing, because they've got handles and you start tracking or lock them on in public. They don't mean to. they get grabbed and pushed, and that really does damage to the mechanism, the RA and the deck, and it's that they just don't work well. Also pulling them out on their tripod all the time, it's just not a good thing. So having this little telescope, the 10-inch at the time, was perfect, and it worked brilliantly for the 5 years I had it. You notice there's a refractor there. Well, that was because Fred liked the refractor. We didn't need it, but it looked good. We had a balance system underneath, the Losmandy balance system, which was quite cumbersome and heavy, and in the way, but that worked fine. The dew remover, and of course we had an aluminium wedge built, which I've got to say at the time we thought was a good idea, but we're learning as we're going, right? But it was a bit clumsy, so I'm glad we no longer have that. Now, the really important thing here about doing what I've been doing is not only the telescope, but getting hold of the camera. So the camera that I first started out with was an SBIG ST6 CCD, and that's a little camera. It was owned by Columbia University, and it was at Auckland Observatory doing nothing. And it wasn't until Stan Walker said, "Hey, Jenny, why don't you take this camera, give it a try, and see if you can use it, and we'll talk." So we did, and it was a learning process. Yes, it was small and a bit, but hey, we learned how to use it. Now, I want to say to the new people out there, if you get offered things like this, like cameras, take them, do your best and get some help to use them, because it's the camera. Without that camera, I wouldn't be sitting here talking to you all this evening. So it's, taking that initiative, take it, give it a try, and you never know what you could do with it. Okay, so that's just another tip. Anyway, so that's what we had to start with. Okay, so a little bit about those who don't know where I'm from. So Farm Cove Observatory is in Pakuranga, Auckland, all right? We decided to call the observatory Farm Cove, of course, as you would. If you have a look at the image here, I don't know if you can see that I'm pointing at things. Maybe I need to use a little pointer. I think I can work out how to get a pointer. Okay, so here is east. This is east. So I've got a great eastern horizon view, a really great view in the east. Fantastic northerly, all right? East is northeast and north. So that's about it for me. My western horizon is unfortunately blocked by, I shouldn't actually do things like, oh, sorry, guys. It was going so well too. Oh dear, hang on. Now it's dead. Hang on. Slideshow, resume slideshow. Steve, if you're there, my slideshow is not working.
Just press escape, because you've probably got the pointer on.
Okay, thanks, Steve. Okay, sorry about this, folks. It was going so. No, it's totally. It seems to be dead. Oh no! Well, that would teach me for trying to be smart and using a pointer. Hold on, something happened then. Hold on. What am I doing? Sorry, folks. Oh gosh. Can you help at all or not?
I can't see what you're doing, but
Can you take control of it? It's just not responding. I can't get it to go back to resume slideshow.
Yeah, we can still see part of the slideshow. Just escape out completely from PowerPoint.
Hang on,
okay,
maybe hold on. We're back. I'm sorry, guys. I won't use the pointer ever again. Okay, I've learned my lesson. Anyway, so that's my view. I can't see in the western sky because I've got no view in the west because of a neighbouring tree. I've asked them to cut it, but they won't. So that's totally blocked most of my western view. As for my southern view, that too is problematic. We've got a house and a roof in the way. I can look south, but there's a few issues there. So, but most of the work I do is in the east, northeast, and the bulge rises up there. So that's the galaxy's centre, the Milky Way. So I'm quite happy with what I've got. So that's where I am in Pakuranga. Just a side note to show you, I'm definitely suburbia. and you can see where the X marks the spot. Now, this photograph was taken from an aircraft approximately 500 feet above and piloted by Glenn Urquhart, who made me extremely ill. So I will never fly with him again. Tipped it on its side, and I felt quite sick for the rest of the day. To give you some idea, so the observatory is here. This is a tributary of the Tamaki River. There's no houses in front of me, which is fantastic. Yes, we get a little bit of fog, but not much. So yeah, that's typical suburbia. Okay, so the current equipment, we've gone up from a 10-inch to the 14-inch. So thanks to Ohio State University, they were kind enough to purchase a 14-inch ACF. So that's a advanced coma-free LX200. It too has been incredibly reliable. There's been issues, as you know, you get issues, but it just needed a bit of grease. So any LX200 owners out there, I suggest grease, maybe once a year, because they really respond to that. I have an Optec TCF temperature compensating focuser, which one would require. Very, very useful because it keeps the tube, keeps my focus, you know, as the temperatures fluctuate and change through the night. We upgraded to a ST8 XME, a dual chip. So it has an auto-guiding chip, which I love. And that auto-guiding chip is extremely useful. I wouldn't be without it, only because the LX200 has a few issues with RA guiding, but hey, that's nothing much. Now, I wanted to talk about the weight belt. So as you can see, I no longer have the weight hanging from the belly of the tube. So now I'm not going to use the pointer. At the very top, I don't know if you can see my little arrow, but at the top of the tube is a weight belt, which has got a lead weight, and it's attached with a Velcro hook. But you have to be careful. It sometimes moves. So I've got to make sure the tape's on there just to keep it nice and secure. There's a dew remover, standard wedge, and I now have a 2.4 meter Kiwi Dome fiberglass, which was kindly bought for me by another collaborator, and that was the Korean Chungbuk University. So I've been quite lucky, but I've worked hard too for them, so that's cool. A couple of things, the dome, I would love to have it automated, but it does need to be modified for that to happen. But that's something we can look at another time, I'm sure. So that's the observatory, and you can see it behind me. Now, the important parts. Okay, so software. I use four software programs mainly, and the most important are these two. So the SkyX, the professional edition, is extremely useful and it's extremely reliable, but it's expensive. So if you're looking to have a really, it's worth it, however. So it controls the telescope. I can download all the latest comet and asteroid data into it. I can put my own data, add my own RA and DEC coordinates to it if I want to. Now, it's going to cost you $300 US to buy the software, and approximately $100 US a year for updates, first year being free. But it's extremely reliable, and I wouldn't be without it. Maxim DL. Now, even though I know there are going to be people out there listening, because I know they're having problems with it, it can be a bit naughty and crash, and it does do that, but not all the time. But it is very reliable, and I use that for camera control and data acquisition. It works with the telescope really well, and but it is really expensive. So you're looking at $600 US for the professional version and $130 US to update it yearly. I want to say here, thanks to the Royal Astronomical Society of New Zealand and the Auckland Astronomical Society for giving me the funds to update the program. So I'm very grateful for that. So thank you. So those two are very important. Make a note. I've put the websites on the slides for you if you're interested. But yeah, they're expensive, but worth it. The next two programs are really important. So Astrometrica, which is the one at the top here. This is for Comet and Asteroid Astrometry. It's a really cool interactive piece of software. It's going to cost you $42 New Zealand, which is nothing. The updates are free. The person who wrote it is always willing to talk, to converse with you if you've got problems and help you out. It's great for, it actually attaches to the Minor Planet Center, so you can download all the latest updates from them. And it's really good at finding things, and it does a great job at blinking and stacking, and it really is worth having. So if you think you want to get into Comet and Asteroid Astrometry, so that's measuring the positions of the objects, that's the program to have. It works very well. The next one is called MuniWin, another interactive piece of software. And so basically its job is to do aperture photometry on CCD images. So especially variable stars, it does a really good job of looking at comparing light from one star to another. And if you're looking at a variable, it'll see the variations, like at the bottom here, that's HP Libra. And that's a 4.5 hour light curve you've got, showing lots of flickering going on. But it's really good software. It's free, but it's a good idea if you're going to use this software. I mean, you send them some money to say thanks, right? So another very important piece that I use. Wouldn't be without that either. Okay, so to give you an idea of what things look like through my telescope, I don't use filters, but that's going to have to change. But so everything I've been doing is raw, as in white light. Now, so you've got an idea of what things look like. So there's old Saturn taken on my mother's birthday. She sadly died this year, so that was for her. So there's 4 little satellites there that you can see. This is a very short exposure, so it's 0.01 of a second. Because it's so bright, and the telescope and the camera, well, the camera's so sensitive, you need to have very low exposures if you're not using filters. But hey, you can see it's Saturn. It's pretty cool. The picture of Leo there, NGC 3267, that was taken with a 5-minute exposure. Remember, I guide. So I use the guide chip for long exposure images all the time, and I always find a star. So it shows the detail in the galaxy. That's a 5-minute exposure. There's a raw image there and a negative as well. Comet Swan, of course, that was pretty awesome. That's only a 5-second image because it was quite bright. Well, when I say bright, it was 13.5 magnitude. On the morning of the 7th of May, which is quite bright with this equipment. But, you can see the tail, and, that's what I wanted. Yes, the nucleus is pretty nasty, but hey, it's a pretty cool picture just for a 5-second image. And of course, you've got Omega Centauri, with all the stars everywhere. So that's another. So that's what, what things look like through this equipment. My main work I do is in full frame. So this is a full frame image, and you can see the details there. Now, for those of you who don't know what we're looking at, this is a photograph that has been inverted. So it's it shows stars. So all those black dots and the very faint ones are stars. Stars so faint that you can't see them with your naked eye. You can't see them with the telescope either. You need a long exposure of 5 minutes. This is a 5-minute exposure taken of looking at microlensing target. That's what it is. So some of those stars are down around 20th magnitude, and but that's basically how I work when I'm doing microlensing. That's what I'm looking for. And just to let you know, once you start looking at all these stars, you get to recognize the patterns, and so you can find things quite easily in a myriad of stars. And this image was taken in the galactic bulge, so that's at the core of our galaxy. Okay, so backyards, what you can do, or what I've been doing in my backyard observatory is collaborative research, of course. And in 2000, and we'll talk about each one of these shortly, but in 2000, with the ST6 camera, that's that little camera, and the 10-inch telescope, I started taking data for the Centre for Backyard Astrophysics, and we'll talk about them shortly. The camera I have at the moment comes from Columbia University, from the Centre for the CBA, they're called. 2004, I stumbled across Microfun, the Microlensing follow-up network, and that's we look for planets, and we'll talk about that too. In 2007, the IAU Minor Planet Centre, where that's the Comet and Asteroid Astrometry. That's been cool. And just recently, I've started doing remote observations of southern comets and asteroids with the Auckland Observatory Research Telescope at Stardome. And I'll talk about that too. So that's going quite well. And that was started in end of November. So let's have a little look about each one of these things, which you guys who are interested in doing some research, backyard, you could do too. So a little bit about the CBA, the Centre for Backyard Astrophysics. They're run out of Columbia University by Professor Joe Patterson. They're basically a group of amateur astronomers worldwide, as you can see by the map, who are dedicated to photometric study of cataclysmic variable stars. And for those people who don't know what that is, a CV, or cataclysmic variable star, is, well, like the little graphic is showing here, so the big bloated object is a red dwarf. The smaller object in the middle of that disk is a white dwarf. And these two stars are orbiting one another quite closely, actually. And the white dwarf, being more massive, is pulling material off that red dwarf into an accretion disk, a disk of material. And so these stars are all very different. Some of them spin really quickly, rotate really fast, others don't, okay? So they're different, but so exciting because you just don't know what you're going to get. Like the image above, now this is a light curve above, I don't know if you can see my pointer, but anyway, this is OY Carina, a cataclysmic variable star. Now this is 10 hours worth of data, and you have no idea how exciting it was once I put all that data that I've taken off the small telescope, the 10-inch, through MuniWin, and it spat out that light curve. And so we can see eclipses, and we can see humps and bumps, and you can see there's lots of information there. The professional astronomers will tell you what they all are. I know what eclipses are, but honestly, they're also very different. You basically get alerts from CBA of what to look at. And here are just a few examples of some of the stars. This is a few. I've done hundreds of CVs, and I just picked a few. The one at the top, V803 Centauri, now that's a very interesting cataclysmic variable. It consists of two white dwarfs, and one of them is a helium white dwarf. And these guys are orbiting really quickly. And I recall, it's around about 20 minutes that they're orbiting one another. They're motoring. So as you can see, very, very different, but really exciting. You get your alerts. They say, hey, have a look at this star. We need data on this. And you take the data. And it's simple. It's easy to do. Most of these targets are reasonably bright. They only require, 25-second integrations, images, whereas microlensing is 300 seconds for 5 minutes. Okay, so the Microfun team, wow. So by accident, I got involved with Microfun, the Microlensing follow-up network from Ohio State. And basically, the amateur and professional astronomers collaborating together to look for planets orbiting other stars in our galaxy. So it's called microlensing. We do it in the galactic bulge, so that's in the core of the galaxy, because that's where all the stars are. So I'm not going to go into too much about microlensing, but what I'm going to do is try to explain in a basic way. Okay, so if you look at the image on the left of the observer, the lens, and the source, basically, as you know, all stars and planets are moving through space. So when a star you happen to be observing, shown here as the lens star, which you can see, or you call it the foreground star, Well, when it passes in front of a background star or the source star, as shown in that image, the light from the source star becomes bent and magnified due to the mass of the lens star. I hope that makes sense. I really do, because I can't point at things. So the observer, the lens star, and the source star for a short time, could be a few days, few hours, line up. And when that happens, the lens star brightens. Now, if you look at the graph at the bottom, it shows that lens brightening as everything lines up. And once the star, once the three objects are in alignment, you get your brightness, it's your maximum brightness on your light curve. And then when they all move away, the star fades back to normal again. Now, this can take hours, days, or even weeks, okay? But that little graph at the bottom there, planet hunting using gravity, is a basic microlensing curve, okay? Okay, so you throw a planet in the mix. So if there happens to be a planet orbiting that lens star, right, while the three of us are all in alignment, and the light from the source star is magnified, that planet distorts that lens and is given away. And the image on the left here shows a light curve that's no longer, like a mountain or perfectly peaked, but it's actually been distorted, and that distortion is the signature of a planet. Now, my job as a backyard observer is to take the data for the professionals to use to find the planets. So the modelers will go to work on it, and sometimes you can actually see that star brightening. You can see the lens star getting brighter and fading again. And I tell you what, it's really exciting. And so far, I think we've been part of, in a collaborative way, about 30 extrasolar planets so far. So it can be done. And I never thought that I could be sitting here telling you back in 2000 or 1999 when we first built the observatory that I'd be involved in such a thing. It's just like, wow. But that's what astronomy can do, you never know. Okay, so the Minor Planet Center. So I've been doing astrometry for quite a while, and I've done lots and lots of comets and asteroids. Here again is Comet Swan for you to look at. The interesting thing here is that a satellite happened to go through the field while I was observing it. Again, this is a 5-second image, and it was only 31 degrees above my roof, and it was at 5:30 in the morning. So it was quite early. I had to get it, and I did. The next interesting thing with astrometry, you can look at asteroids. And just this last month, I was involved in the International Asteroid Network timing accuracy campaign. So they wanted to see how accurate we were at actually observing this near-Earth asteroid, which I've got to say was damn difficult to do because it's moving quite quickly. So the program was over 3 days, the 9th, 10th, and 11th of November. I got 1 day because it was cloudy, which is really damn annoying, but never mind. So I've got a little movie here to show you of it moving. So there's about 12 images in this little video, I think, and they're 5 seconds long each. All right, so you can see it. Now, the reason it's wobbling like that, you get a wobble, because that's either seeing or the tracking, just not quite just giving it, but it's pretty damn good. And it was actually really hard to image this. I'm hoping that the accuracy was good. We had a meeting online about it. Whoopsie. And we're going to find out who was the most accurate, and they're going to give a prize. So I'm pretty sure mine was okay. So that's what you can do looking at asteroids. And by the way, I put this little video together in Maxim DL so that you could see it moving along. So that was pretty cool. Okay. All right. So then, of course, the Auckland Observatory research, I've been logging on from my home computer, which is great, to look at southern comets and asteroids. So far, since starting, I've imaged 15 comets, 3 asteroids, and of that data, 9 of the data from those asteroids and comets have gone to the Minor Planet Center. You know, often when you look at the sky, you'll download the updated information, and it'll say that the comet's magnitude 13, and you look at it and it's not visible. So, you know, some of them are just not visible. We've had a few issues, you know, with the telescope, but we're hoping we'll get onto that and get that nice and stable, and I can take a lot more southern data, which should be really cool, and western too, because since I can't get them. Okay, so now a little bit about the discoveries that I've been involved in. You know, as a backyard, as an amateur observer, I mean, you can do it too, seriously. You just need the equipment, you really do, and a little bit of initiative, enthusiasm goes a long way too. So let's have a quick look. So, you know, this happened in 2000, so just after the observatory's built. This was done with the 10-inch telescope and the small ST6 camera. So we were asked to have a look at a star called Virgo 4. And Fred went out, and I thought, we'll do it. 16.3 magnitude. It was quite faint for a 10-inch. And what do you know? We took the data. This was over a 6-hour period, and ran it through MuniWin. And wow, there's some eclipses. And here they are in the little paper here. There's 3 there. Now, these were, I think they're approximately 2 hours between each eclipse. But what we discovered is that it was a new type of eclipsing dwarf nova, and it had eclipses. So we were rapt. And you know, the most exciting thing of all that I'll never forget is in the mail. It came in this really thin brown envelope from the Commission 27 of the IAU, all very official. And you know, you open it up, and there was the paper, and this here was from that paper. So that's in a little frame now. So that happened in early March. So that was pretty good considering we'd only just started. In June, since we'd only just started. So that was the first thing. Now, the thing that was really unexpected was being involved in a planetary discovery, an extrasolar planet discovery. I mean, who would have thought? Remember, I had a 10-inch telescope. I had an ST7 as a camera. We'd upgraded it. I got given one from the Centre for Backyard Astrophysics. And when the alert came through to do this work, you know, it happened to be fine. We were in clear sky. Grant from Auckland, his team as well. And so over this was over about 3 or 4 nights. As you can see, that beautiful lovely light curve of a gravitational microlensing is not there. It's actually been distorted. And we happen to be lucky enough to be right on the really critical points of getting data for this planet. So you can see the planet, you know, you can see the distortion it's made in the light curve, you can in the magnified lens. And it turned out to be a 3.5 Jupiter mass planet. So that was very exciting. For Grant and I suppose I can only speak for myself, but it was a really weird time to be part of this, because the media were all over it. It was just like, wow, you know, CNN and Fox News and BBC, and the Chinese wanted to interview you, and that's because of the little telescope. The cool thing, though, is Sky and Telescope, the American version, gave us one of the top 10 exciting discoveries for 2005 as being, you know, amateur astronomers involved in this type of work. So that was pretty awesome and totally unexpected. Then 2006 comes along, and what do you know? We actually take part in the collaborative discovery of a solar system. You know, a solar system similar to our own, or Jupiter and Uranus mass, and these planets were around about the same distance to the parent star as well. So it was quite similar to our own solar system, proving that solar systems are quite common and are out there, as we know. Now, if you look at this weird light curve, you can see the distortions and you can see the signature of the planet. This was really annoying because this particular event, I was in cloud for a lot of it. Now, Grant at Auckland on the Auckland Observatory team, they're 15 kilometres away from me, and they were clear. And you can see the data here, who got what. And it's so frustrating. It's knowing that something really cool's going on and you can't take data. This event sort of took place over a few days. But hey, I mean, wow, you take part in discovering a Jupiter and Uranus mass. It was very exciting. So that was in 2006. Then a really weird thing happened in 2009, as it does with astronomy. And these are 3 5-minute images of a comet, Comet Hill, who this comet was discovered in 2009. And I decided, look, I want to take an image of it because it was newly discovered, and I had just finished observing a microlensing event, and I thought, I might as well look at this new comet. But here's the thing with astronomy, with what happened next is I decided not to drop the exposure time from normal 300 seconds for microlensing because I was too lazy for this comet, which should have been probably 60 seconds. I left it at 300 seconds. And just as well I did, because this is what happened. Okay, so here's a 300-second or 5-minute image of Comet Hill. Now, you're going to ask me why you could be thinking, well, why the hell is it sitting there, not in the middle? Well, I need a guide star. And if I have to move my object I'm looking at off center, I will to get it. So just as well, I did. So if we look at this image, you'll see the Comet Hill quite clearly. You've got an asteroid over here, quite bright. Once I put the data through Astrometrica, it showed that, yeah, that was a known asteroid. We know the comet is Comet Hill, but there's this object. I don't know if can you see my pointer, Steve? Oh God. All right, how do I do that? Shall I risk the pointer, do you think, Steve? Okay, I'm going to risk the pointer. Okay, please don't die. Okay, so I'm going to risk the pointer again, everyone. Let's start this. So this just under my pointer is a little asteroid. Now, that's very faint. Oh, you can't see the pointer either. Oh dear. Okay, well, how am I going to do this? Hold on. Oopsie. How do I do it then? Right, guys, so if you have a look at Comet Hill, if you come straight down, there's a brighter star and another one just below it. Well, there's a little asteroid. Oh, now it's not even working. Oh no, here we go again. Okay. There's a little asteroid moving in this field. I'm sorry, I thought you could see my pointer, my laser pointer. But just below Comet Hill, there's a little faint. If you just look for a bit, you should see it. Anyway, this turned out once. Oh no, sorry guys, I'll get rid of that. Once I put the data through Astrometrica, it showed that this object had not been discovered. So it turned out that I had found a new object, a new asteroid, which was really exciting. So I got an email from the Minor Planet Center from Brian Marsden, who was the head at the time. He's now, unfortunately, he's deceased. And he's congratulated me and said, well done, this is a new asteroid. So here's some information on it for you. He also gave me a designation of 2009 SA1, and there is the information there. So on the 16th of September 2009, now I discovered it at opposition. It happened to be at opposition, so closest point to Earth in its orbit. Its orbit is 3.5 years, so it takes 2 of those orbits to come back to that close opposition. So it's approximately 250 million Ks from the sun at opposition. It's 1,000 meters in diameter. approximately. And I was able to name it, but on condition that I had to wait 7 years for it to complete those 2 orbits to come back to opposition again when it was at magnitude 19.4. If it had been on the other side of the orbit, it would have been just way too faint, literally ridiculously faint. So 7 years it was. And when that 7 years was up, I put in a name for a name. And thank you to Grant Christie from Auckland Observatory or Stardom Observatory. He actually took an image that we used for the media, and the circle marks the asteroid. So that's 2009 SA1 on its 7 years later, just visible, it was amazing. And so I wanted a name that was inclusive so that we could include everybody in the discovery. And so I named it New Zealand. And so New Zealand is there in the sky, X. So there it is. And, hey, I never thought I'd find an asteroid. I mean, goodness. But again, it came down to being too lazy to change the exposure time from 5 minutes to 60 seconds. If I had kept it at 60 seconds, I would never have seen it, never. So, hey, I like to image in 5-minute exposures now. Now, just after that, this happened. I got an email from a Bob Brocky from the Dominion, who writes for the Dominion Post, and he thought it was a cool story, and wrote an article about New Zealand, and accompanied that article with that, which I thought was pretty cool. So I've blown that up, and that's on my wall. My grandkids love looking at it as well. So the asteroids are next. So what else? Wow. Well, in 2013, we took part in the co-discovery in a discovery of an Earth-like, a 2 Earth mass planet orbiting a binary star. Go figure. So for all those who are interested in the information, it's there for you to read. So it's a small, very cold world. This is the light curve, and you can see the distortion in that beautiful light curve, the standard microlensing curve. So the planet gives itself away. So the modelers, of course, got hold of the data and modeled it all up and found that it was definitely binary, which was quite cool. You can see there was a number of New Zealand telescopes involved in that discovery, in that co-discovery. So there's the Moa telescope in the South Island. What we've got John Drummond at Gisborne, at Possum, and then there's Auckland, and there's me, and there's Turitea. I'm not quite sure how you spell that or how you pronounce that. So there was a real collaborative effort, and you can see everybody's data there. Unfortunately, again, cloud came in, and so some of the data we weren't able to get on that curve. But hey, a planet orbiting a binary system, I mean, and similar, to Earth masses is pretty good. And I have to show you this because this is cool. So you know that I'm into Star Trek in a big way, and never miss anything to do with Star Trek ever, even now. So just after the discovery of BLG 071, and remember, that information went all around the world that these amateurs in Auckland had done this work and helped to discover this planet. So in 2006 at Armageddon, this lady was at Armageddon. She was a guest, and I'm sure you know who this is, those Star Trek fiends out there. So this is Gates McFadden, who was the doctor in space. And I was working at Auckland Observatory at the time, and she came looking for me and asked for my signature. And I was just like, what? And I honestly have no idea what I wrote. I don't even know what I wrote on. It was just weird. The whole thing was weird. And I said to her, look, could I have yours? And explained how I used to watch her on TV, and I love Star Trek. And she was most obliging. So she picked up the yearbook, 2006 yearbook, and in the section on meteorology, she wrote this. So to Jennie, from the doctor in space to the real discoverer who went boldly where no one went before. I mean, that was pretty damn amazing. Who would have thought, So astronomy does weird things. It's just, you've just got to get out and do it, And to end, I wanted to end with just 2 slides of what next. Well, I'm sure if John Drummond's watching this, he'll totally understand what this means. So I would love to discover a comet. I'm looking forward to seeing Comet Leonard, which looks by all accounts pretty awesome. The discoverer of that was Greg Leonard, of course, from Mount Lemmon Observatory, but I can't find what telescope he used to discover it. Now, I'm told that maybe finding a comet might be pretty tough because there are survey telescopes that are just hoovering up the sky and looking for these things. However, you never know. And what I think I've proved is that I never thought I'd be involved in any of these discoveries, but I was. So it is possible I could discover a comet, and I've got my fingers crossed because that would be really awesome. And finally, I leave it to my grandchildren, so I want to inspire them. And this is Ruby up on the ladder, who loves coming into the observatory, and little Maxie there with his cool planet bib. And so if I can inspire them to get into astronomy, like I was inspired by members of the Astronomical Society, so be it. It'll be really cool. And thank you. That's it.
Thank you, Jenny. We made it through without any more technical glitches.
I'm really sorry. I'm so sorry.
That's all good. We've got one question. There is time if anybody else wants to get another question in. But we do have one question from Robert Patterson, who says, "Hi, Jenny. With your pier sitting on clay, did it take time to settle polar alignment wise?"
Yeah, it did. It's actually not sitting on clay. We actually dug out the clay. Lots of rocks and fine scoria and stuff, but not really. I mean, once we got it all settled and set in place, everything seemed to work really well. Sure, there's issues, but not really. But I tell you, that clay is a real problem. It's just, but no, everything seems to be good. I haven't had any issues. There's been no movement. We watched that quite carefully. The polar alignment's not bad. It could be better. But at the moment, Robert, I don't want to get changing things because the auto guider is working just fine at this stage. But thank you for your question.
Thanks, Jenny. Well, there aren't any more questions, so I guess it's just to me to say thanks very much for a really, really interesting presentation. I really enjoyed it. There was a few things in there of your story that I didn't know.
Okay.
On behalf of the Society and our members, thanks once again.
No worries, anytime. Thank you for having me.